Vice-Chancellor, distinguished guests and colleagues, ladies and gentlemen. On behalf of CES and CUSP, as joint hosts of this event, it's a real pleasure and a delight to open the 4th annual Roland Clift Lecture, this year presented by Professor Johan Rockström, who's Director of the Stockholm Resilience Centre. We're honoured to have Professor Rockström as our speaker. His work, especially on the Planetary Boundaries framework, has achieved international acclaim and really captured the imagination of sustainability specialists, policymakers and scientists alike. I know that we're going to be in for a rare treat. The first Roland Clift Lecture, which is CES's premier annual event, was presented in 2013 by Roland himself. He remains a much appreciated, active and distinguished emeritus professor in CES. And I'm delighted to say that he's with us today. Welcome, Roland.
Thank you.
This year, Roland has also been honoured by the award of the George E. Davis Medal of the Institution of Chemical Engineers, the institution's highest award, for his unstinting contribution to science of sustainability and industrial ecology, which is the subject of today's event. At CES, we've been greatly influenced and inspired by the work of Johan and his colleagues, and in partnership with Unilever, ran a workshop and follow-up activities to explore ways in which the planetary boundaries concepts might be applied in company decision-making. This year, some of that work has been reported in a paper led by Roland with CES colleagues, Professor Rockström, and many international collaborators. Vice-Chancellor, you may also be pleased to know that this paper is considered to have some merit regarding REF. I'm now delighted to hand over to our President and Vice-Chancellor, Professor Max Lu, to give his welcome to the University and introduce Professor Rockström's lecture. After the lecture, we will have some time for questions and answers, followed by a vote of thanks, which will be kindly presented by Camilla Tulmin, Chair of the CUSP Advisory Board. Vice-Chancellor.
Thank you very much, Richard. Distinguished guests, ladies and gentlemen, it's a great pleasure for me to welcome you all to this 4th Roland Clift Lecture. We are very honored to have, of course, Roland Clift, the founder of CES, of 25 years of achievements, and that I'll touch on that later. And of course, our guest lecturer, the Roland Clift Lecturer, Johan Rockström, who is the Executive Director of the Stockholm Resilience Centre at the Stockholm University, and the 2017 Hillary Laureate. And I'm very pleased to see the 2016 Hillary Laureate, our own, very own Professor Tim Jackson, also in presence tonight. It's always a great pleasure for me to be amongst the scholars, the researchers, attending lectures and talks like this, particularly those given by eminent speakers, such as Professor Rockström. I'm interested in this particular lecture because the topic is so relevant and so important to one of our mission of this great university, that is to make a difference in shaping the future of our planet. Yesterday, I was very delighted to brief all our staff on our corporate strategy, a new corporate strategy for the next 5 to 10 years. Among our high priority research themes, we have urban living and sustainability as our strength as well as focus for our future research. Of course, the work of the CES and CUSP are close aligned with those research themes, as we can see. Work in these areas is critical to finding solutions to our global challenges, as well as measuring the environmental impact of development and how we manage it. And these issues across many boundaries, and they could be industries, the ecology, and society. And that is why we are so excited about the research direction in this field, particularly by our top researchers in CES and CUSPs. And through the pioneering work of our researchers in sustainability, and we heard the industrial ecology award-winning work from Roland, in particular in areas such as environmental values and resilience, carbon management, and corporate social responsibility, sustainable economic development, and more. We are creating the next generation of professionals and leaders, as well as new knowledge and breakthrough work that will guide the development. And these are all going to make a positive impact to our world. So Professor Rockström's research is closely related to the work here, as we heard from Richard. And tonight, he'll be sharing his insight into planetary boundaries and how the concept would apply to decision-making in business and strategy. Professor Rockström is well known to many of us here tonight and to colleagues in the CES as well as CUSP. Is also a valued collaborator, as we heard earlier from Richard, for some of the publications we jointly publish. I'm told that Professor Rockström has recently contributed to the Lancet Commission on Pollution and Health, which is another area of our strong research capability by way of Professor Prashant Kumar's Center for Clean Air Research at this university. As some of you will be also aware that we already heard, the university has celebrated the 50th anniversary, and this is towards the end of our 50th anniversary celebration. And of course, the Center for Environment and Sustainability has played a crucial role in the past at least 25 years of the university's research. And that is 25 years of world-leading multidisciplinary research and 25 years of producing world-class alumni, graduates who are going to make a difference, and 25 years of collaboration with industry, government, and the communities. You can see that we're very proud of CES, and this is because the CES was set up by Roland Cliff, very visionary chemical engineer professor, and has become a premier center of excellence in the UK for the interface between the environment, society, and sustainability. What an achievement, Roland. Especially if I remember, from early days I knew Roland's work, but also I've been told that Roland founded the center in a pod cabin just with 3 members of staff, and that was 25 years ago. What an achievement. Congratulations. Finally, I would like to now thank Richard and Tim Jackson and Deidre, Linda Gisner, and all the team members of CES and CUSP for organizing such a wonderful event and this lecture. And of course, thank you all, ladies and gentlemen, for your participation this evening. I hope you look forward and you enjoy this very stimulating lecture. So now, ladies and gentlemen, may I ask you to join me in welcoming for his lecture, Professor Johan Rockström, please.
Good evening, everyone. It's a great honor to be here and to walk through a scientific journey taking us to what I will argue be the new paradigm for human prosperity on Earth, a redefinition of global sustainability. And fundamentally, it starts from a very challenging point that the last 40 years of advancements in Earth system science, whether we like it or not, forces us to pose a completely new question. The question of whether we are actually in a position as a world society of destabilizing the entire Earth system. The risk of us as a world to push the world out of its quasi-equilibrium state into a state that potentially is not stable and able to support sustainable and welfare development for humanity. And this is, of course, doubly challenging, particularly for a Scandinavian who has, of course, as you can imagine, as my biggest hero, former Prime Minister Gro Harlem Brundtland of Norway, who set the stage for our modern thinking on sustainable development. With the three pillars of sustainable development, the human, the ecological, and the economic pillars, which were launched in 1992 at the Rio conference, we simply have to admit, science is clear, the observations we have shows that this has failed. The separation in pillars never worked. It turned into what I've called a Mickey Mouse economy. An economy that has grown, yes, thank you very much, at the expense of human capital and natural capital. Fundamentally, actually, we've been able to rely on a resilient Earth system to a point where we have had basically a subsidy provided by the Earth system to a point where no invoices have been sent back to societies, and a rich minority have been surfing along in a very, very effective way on this free subsidy of greenhouse gas emissions, free exploitation of biodiversity, free deterioration and transformation of terrestrial and marine ecosystems. But now we've reached a saturation point, to quote Professor John Schellenhuber of the Potsdam Institute, or to quote Professor Will Steffen at the Australian National University, that we are now hitting the biophysical ceiling of processes that regulates the stability of the Earth system. So we need a shift. There's something big happening. So it was not a coincidence that we in 2007 gathered global environmental change scientists to stand basically, as Newton quoted, at the shoulder of giants to take the next incremental step in science. Because we have so much evidence of now having saturated the Earth system that, of course, the next natural step was to ask the two fundamental questions. What are the Earth system processes that regulates the stability of the Earth system? And for those Earth system processes, could we scientifically define quantitative boundaries beyond which we are at risk of triggering irreversible feedback dynamics that could take us to a point where we could push the Earth system away from its equilibrium state, but within which we can have a safe operating space where we can successfully support human development across scales into the future. And what you see here is the green safe operating space, but clearly the yellow zone of uncertainty as well, because science along these boundaries have a very high degree of uncertainty zone. We did apply the boundaries, as you may be aware, applying a precautionary principle, saying that the boundary within which we can have a safe future for humanity should reasonably be, if you apply a values-based approach, at the lower end of that uncertainty zone. That's the only part of normative value in the planetary boundary framework. And I'll come back to exactly these definitions of the planetary boundaries. But that's just a key message, that it's not a surprise that science is now addressing the safe operating space or guardrails or tipping elements at the planetary scale. Social science has engaged very heavily in this endeavor, and it's fantastic, and I'm very proud to have friends and colleagues, not least at the University of Surrey and in the UK in general, addressing, if we have a biophysical ceiling that we have to respect, clearly there must be a social floor, which is fundamentally important in this increasingly turbulent world that we are facing in the Anthropocene. The justice and equity dimensions of welfare distribution, but also of sharing the remaining ecological space on Earth in order to have any chance of delivering development in the future. We also have some drama here, some real drama, that this question of whether or not we are at risk of pushing the Earth system out of its equilibrium state, quite recently in the Anthropocene Working Group, which is organized through the Geological Society in the United Kingdom, on questioning whether we're actually leaving our current geological epoch, the Holocene, into the Anthropocene, showing that we are very unlikely to have a chance to return to the Holocene due to the climate forcing that we have already kind of caused in the Earth system. The evidence from a recent paper from the Potsdam Institute from Ganopolsky et al. Showing that, well, if it's unlikely, as Clark et al. Show, that we can actually return to a Holocene state, it's equally unlikely that we can push ourselves into a new ice age, that we have in fact loaded the Earth system with so much forcing that we are probably never more going to see a return into the Milankovic cyclic of 110,000 years of in and out of ice ages. So we are truly a geological force of change at the Earth system. To the point that as a follow-up on the planetary boundary science that was published last update in 2015, we're right now, as we're speaking, this is unpublished work, exploring the kind of grand question for humanity, I would argue, that we know we have 3 limit cycles of the Earth system. The 100,000-year glacial cycle, you could think of the x-axis here as sea level rise on Earth, and the y-axis here is temperature. So when sea levels go down some 70, 80 meters on average, temperatures go down 3-4 degrees Celsius, we enter this self-reinforcing cooling feedback mechanisms that locks the Earth system in its limit cycle of glaciation. But then we have the small circle here, which is the grand challenge of what are the boundaries within which we can still, with a high probability, have the Earth system remaining in a manageable state for humanity. In an interglacial state, the state we've been in since the last ice age, the virgin ice interglacial state is that little line under the 2 degrees Celsius point there, which is the last 12,000 years of interglacial. We are clearly out of that virgin state of interglacial. The big question is therefore, how far can we push the system while managing and being stewards of the planet to remain at a point where we do not push ourselves beyond a threshold, here illustrated by the 2 degrees Celsius line, where we are at risk of having self-reinforcing feedbacks that could take us into a hot state. The James Lovelock kind of Gaia breakdown. And that we now, whether we like it or not, have to pose this question, because we're starting to see the cracks in the system in terms of maintaining what actually still is an Earth system that has net negative feedbacks. Net negative feedbacks being the ability to dampen and reduce our stress on the Earth system, and that positive feedbacks have still not been triggered, but we're starting to see the indications that they can be. So in summary, what took us to the planetary boundary science was actually the advancements in 3 strands of research. One, that we have evidence of we as humanity now having entered a new geological epoch, the Anthropocene, anthros for humans, that we now constitute the largest force of change on planet Earth, exceeding our distance to the sun or volcanic eruptions or earthquakes. The evidence that the Holocene is the interglacial quasi-equilibrium state of the Earth system, which is the only state we know for certain can support humanity and world development. And I'll come back to this. But the Holocene is a unique, we even call it among ourselves in our science team, as a Garden of Eden, which is the only state we know that enabled us to go from being hunters and gatherers that we had been for 100,000 years as modern humans in an ice age, and then suddenly shifting over to be sedentary farmers and starting the evolution some 8,000-9,000 years ago into what we today know so well as modern societies, able to differentiate roles and expertise from food production all the way to technology advancements. And the evidence that Earth system tipping points are real, meaning that we've built up our societies at large on the false assumption that nature is stable, that environmental processes change very slowly, they change linearly, and they change therefore predictably. Well, science has now shown very clearly, I would argue even overwhelmingly clearly over the past 30 years, that it's the reverse. That nature has a resilience from local ecosystems to the big ice sheets to the atmosphere and the ocean systems of actually buffering and therefore changing, yes, linearly and incrementally, up to a certain point where the absorption capacity has gone down so much, so an incremental change can lead to abrupt shifts by crossing tipping points and a feedback shift that takes it to another state, like when a rainforest tips over and risks becoming a savanna. These 3 strands of science is what took us to the planetary boundary framework. The recognition of the Anthropocene plus Holocene as our reference point of a desired state, plus the risk of tipping points, is what took this theory to a framework. Now, as a starting point for this journey into the science behind the planetary boundaries, I think it is also important to take a little bit of a philosophical step back, just at a starting point. We have evidence from observations actually, not from theory or simulations, but from observations, that it is in the last 50 years, when we entered the Anthropocene, the great acceleration of pressures on planet Earth, that has shifted the conditions on Earth over the past 10,000 years. So in 50 years, we've changed conditions on Earth as they've been for the past 10,000 years. But we have also growing scientific evidence that it's actually what we do in the coming 50 years that will be determining the outcome for the next 10,000 years. And I cannot see really because the light's in here, but I have a sense that you're also sharing some gray hair as I have, and meaning that large parts of us in this room have been, in the journey getting into this state. I'm willing to admit I'm one of the culprits. We've been part of taking us to the Anthropocene point where we are today. And, with health hopefully in order, I hope to be part of at least a part of the journey into the future as well. So we are essentially the generation holding the responsibility, but also the opportunity of securing a future for humanity in our hands. This is the decisive moment. We are right at that knife edge of having been here for the 50 years that took us to this point, but also being part of putting, the decisions in place that will determine whether we take us into a positive or a potentially unmanageable direction into the future. That is why it's so positive that we have the Paris Climate Agreement, that we have the Sustainable Development Goals now signed, that we for the first time in human history on Earth actually have a roadmap of a desired future for humanity, which for the first time defines aspirational goals for social and economic equity and development within planetary boundaries. We do not see yet that the political leadership has really understood what they've signed, but we do see that finally there is something happening. There's something starting to move and recognizing this direction. Well, what's the evidence behind this kind of dramatic statement around our responsibility and the journey we've made? Well, as most of you certainly know, it is observations. It is the synthesis on the great acceleration coming out of the observations since the Industrial Revolution that happened in the UK. The x-axis here for all these parameters is from 1750, the Industrial Revolution starts, until today. On the left-hand side on red are the social exponential curves of population growth and economic growth and material flow. And on the right-hand side, we see the equivalent pressures on the Earth system with parameters that range from carbon dioxide to sulfate use, deforestation, ocean acidification, air pollution, all the way to the one that many scientists today argue is the most worrisome parameter, which is that we've entered the sixth mass extinction of loss of species on Earth, the exponential curve of loss of biodiversity, from pollinators in agriculture to the prime predators in ecosystems. And that this is observations which lies behind the evidence of having entered the Anthropocene. But that evidence is really not the key message. The key message, which certainly is not sunk in, is the following. So this is how the curve looks like if you pack everything together in terms of the rising environmental pressure on Earth. Up until 1955, when we're 3.5 billion people, we have actually very limited impact as humanity on the Earth system. We have environmental disasters. We have everything from the Maya to the Inca to the Eastern Island to the Mesopotamian irrigation societies potentially collapsing due to over-salinization of irrigation systems. But we're not affecting the planet. It's 10 years after the Second World War, we're 3.5 billion people, and that's where we put in the high gear on what has been called today the Great Acceleration. It seems like this is the point where we've come so far in terms of markets, in terms of globalization, in terms of technology, in terms of fossil fuel energy systems, that we can really put in the high gear, and off we go. But the Earth system is so resilient that there are no invoices being sent back. The system actually delivers. It delivers remarkably. Actually, there are scholars saying that, how can we claim that we're facing potentially disastrous environmental change when longevity has risen so well, when we are 7 billion people eating more food than when we were threatened in a Malthusian way by kind of a collapse of food production in Asia. Well, I would argue that it's such an enormous mistake, and it is that we've been pushed in a lulled in a comfort zone by the resilience in the Earth system. I mean, the warnings came early, as we know. Rachel Carson wrote her Silent Spring in 1962. The Limits to Growth came out in 1972. But as you see, I mean, they were shot down on kind of wrong footing in terms of science, but you could basically excuse them because we had just started our journey. You could argue as an economist or a business leader that, you know, why are you worrying so much? We were just at the beginning on a curve. Who knew where the curves were going? These were intellectual, early warnings from very visionary, bright-minded people, but they were shot down. And then off we went, and the Earth system continues to deliver without any invoices up until a point where suddenly we start seeing things cracking. And I would argue that today we have scientific evidence to put a date on that point. And that is, we entered the Anthropocene in 1955, but we reached a saturation point 1990. Plus minus a few years. But you know, it is in 1989 that we reached 350 ppm in carbon dioxide concentration in the atmosphere. It's actually in 1989 that the Baltic Sea collapses from its cod-rich, oxygen-rich state due to eutrophication overfishing. It's in the late 1980s that we see the first collapses of lake systems in the US because of eutrophication, which gave Steve Carpenter the Stockholm Water Prize just a few years back. It's in 1990 that the cod fisheries collapse out of Newfoundland, a famous story of mismanagement and overexploitation. It's in 1990 we see the first observation of accelerating ice melt in the Arctic. We start seeing the Ilulissat ice fjord starting its exit of major icebergs. Something happened around 1990 that starts to indicate that we're starting to see non-linear changes across systems in the Earth system. And it could be, and I say could be because this is not published and it's kind of still in a scientific hypothesis, that it's in 1990 that we reached a saturation point. That is the point where we filled up the system. There's simply no more biodiversity out there, there's no more ocean acidification, there's no more heat to be taken up in the atmosphere of greenhouse gases. And it's from 1919 onwards that we have reached a point where we need to rapidly transition into a sustainable future. And it's quite an interesting time because as many of us who've been in environmental work for many, many decades, we know that, and the United Nations even wrote a report on it, that the lag time between scientific warnings and actions is roughly 25 years. You know, it doesn't sink in from passive smoking to acid rain until roughly 25 years after the science has been established. Well, could it be that we've reached that point now? That it is something like 25 years since we've entered this saturation point, and finally we're starting to see a transition where sustainability and planetary challenges are being understood as something necessary and potentially also the only pathway for humanity in the future. That's one potential conclusion of this, but the other one is also to recognize it means that it is not so that we have been shouting wolf forever. Absolutely not. It is very recent. Actually, you may know that those hockey stick curves, the evidence behind the Anthropocene, when were they published the first time? Well, they were published in an International Geosphere Biosphere Program report led by Professor Will Steffen in 2007. 2007. The actually thorough summary came out a few years later. That's not so long time ago. I mean, the knowledge and the evidence is quite recent. So that is why I would argue that the political leadership is actually waking up in a quite promising and positive way. So it is a kind of a mind shift occurring, and I think we're starting to see the first signs of this. The recognition that, yes, we've always thought that we were a small world on a big planet. We've kind of built our economic system around that. We've built actually our governance system around that. I mean, President Trump is behaving as if we still are a small world, a big planet. You know, US can go its own way. We don't care about our neighbors, as if we don't share the same saturated atmosphere. Today we have evidence that we are no longer a small world on a big planet. We're now the big world on a small planet. The planet is small not only in terms of communication and terror and geopolitics and global trade, it is small also in terms of sustainability. What happens in one biome on planet Earth immediately is interconnected with human prosperity and opportunities in other parts of the world. I actually today and very clear. For example, when I get a chance to talk to the Swedish government and speak to my own finance minister, say, well, it's of equal importance for you to be very preoccupied with your own GDP growth and jobs as it is to check the rainforests in the Amazon. Are they stable or not? Because they are today interconnected and have direct impact on the abilities for economic development in a country like Sweden. We are now in this saturated state. And we have so much evidence. And I put this graph immediately because I feel that this is probably the most important scientific graph for any climate negotiator to have in his or her hands next week in Bonn. Because this is the first time there's an effort of combining the Holocene as a Garden of Eden, the future of the Paris Agreement, with the risk of tipping points that could take us in a very irreversible, unmanageable future. So what you see here is on the x-axis, we exit the last ice age 20,000 years ago, and we reach today. On the y-axis, you have average temperature in degrees Celsius. And, well, the reminder, we're in deep ice age just when the average temperature is roughly -3 degrees Celsius on planet Earth. We exit the last ice age roughly 12,000 years ago. We enter this Garden of Eden, 12,000 years of Holocene stability, as you see. Remember, this is a ±1 degrees Celsius interglacial. Extraordinary. We've actually had a relative stable Earth system. And then you have the Paris Agreement, the Paris range of going as far below 2 degrees Celsius as possible, aiming for 1.5. So reminder one, even if we succeed with Paris, we are outside of the Holocene equilibrium maximum temperature, which is why, of course, there is calls for recognizing that climate resilience and climate adaptation are absolutely necessary. We're not anymore in a question of returning to some kind of virgin state. It's a question of remaining in a manageable state of the Earth system. But then what you see here is, on top of all this, we have loaded the uncertainty range of the knowledge we have today on at what temperature range are we at risk of pushing systems across tipping points that could lead to irreversible change. And irreversible meaning that over the next 200-300 years, we cannot turn back. And that square you see to the left there is the range that dips into Paris, meaning that these are systems where the scientific evidence as it stands today, the length of these columns is the uncertainty range in science, but as you see, they dip down into the 2 degrees Celsius range in Paris. So for example, the most dramatic in my mind is that coral reefs, according to the scientific knowledge we have today, have an uncertainty range that is entirely within Paris, meaning that, to put it very bluntly, as far as we know today, even if we reach 2, we are very likely to no longer have tropical coral reefs on planet Earth. Then you see alpine glaciers, Arctic summer sea ice, Greenland, that has a large uncertainty range, but it dips into 2. We can no longer exclude pushing an on button of irreversible melting of the Greenland ice sheet, even at 2 degrees Celsius, which would actually commit humanity to a 7-meter sea level rise. Not that Greenland would suddenly take us to 7 meters over a decade or 2 or 3. It would probably take centuries, but it would be irreversible. We would be the generation that pushes the on button, and then it would irreversibly commit future generations to that future. So this is a reminder of why the Paris range is so fundamental and why it had such strong scientific support that we have to, go under 2, and that we need a precautionary principle and understanding the tipping elements. And of course, this is, as we know, unevenly distributed. Now, you're not so far north as we are in Sweden, but I think it's quite telling that President Barack Obama, essentially the last thing he did on science in the White House was to gather scientists around the Arctic and commissioning a report that several of our colleagues in the Earth League were part of, showing that 2 degrees Celsius average warming on Earth means 5 degrees Celsius warming in the Arctic. It's just a reminder of the amplification effects that can reach our part of the planet, which would lead us into territory that is very questionable how easy it is to manage. This is the data that came out, which I would argue is also something that has actually almost shocked many scientists, that the Great Barrier Reef in Australia was in the 1998 El Nino unaffected largely unaffected by bleaching due to the El Niño event. And the conclusion at that time was that Australia is managing its Great Barrier Reef so well that it withholds biodiversity and has limited pressure on sediments and eutrophication, so it actually could have the resilience to withstand the El Niño bleaching. This is the 2016-2017 El Niño event, showing in 2016 how the Great Barrier Reef was severely bleached by the El Niño. And the bleaching itself is serious, but of course, if it gets a few years of non-El Niño, it gets a chance to recover and come back. But 2017 was a follow-up El Niño event this year, and the conclusion in the latest data is in fact that 30% of the northern part of the Great Barrier Reef has crossed the tipping point. And it goes gradually down to the south as waters get colder, but the conclusion is that 50% of the Great Barrier Reef has crossed the tipping point and is irreversibly lost. The Great Barrier Reef, the strongest and most resilient marine coral reef system that we have. So this is just to show what happens already at 1.1 degrees Celsius warming. Then we have the data coming out of research from the Amazon on the risks of tipping points in the Amazon from Carlos Nobres and colleagues. The latest figures on the dependence on moisture feedback from a warmer climate on rainfall patterns in the Amazon, showing, for example, in this seminal work, I would argue that a large part of the rainfall in the Amazon comes from moisture feedback, convective vapor fluxes in the intact rainforest that actually determines or has influence, for example, on freshwater supply to cities like Sao Paulo. And then comes the big drama, I would argue, just a month back with the Woods Hole Institute paper showing that all the three remaining big rainforests in Latin America, in the Congo Basin, and in Indonesia have now tipped over from being a carbon sink to now have become a net carbon source. We don't know yet really why. It's certainly a multiple drivers of social, ecological changes, but it's a signal because this is, I would argue, kind of the scientific nightmare is when things go from negative feedbacks, dampening, to positive feedbacks, self-reinforcing. And of course, the big biomes are still net negative feedback dominant mechanisms. They actually keep the planet stable. So it's not surprising that our equation I showed earlier led to the planetary boundary framework. It was published the first time in 2009, which, as I mentioned, gathered global environmental change scientists to really try to put the puzzle together. The Anthropocene, Holocene as our desired reference point. What a beauty it was to have all that glacial data and all that anthropological research showing that it was in the Holocene that we were able to establish sedentary societies as we know it. It was in the Holocene that we can see food production and world civilizations evolve and have that as a reference point because we have so much science to support the reference points of what are the limit cycles that kept the Holocene intact. And load with that also the tipping elements research, which gave us this ability to really scan off, turn every stone we had on what are the systems that regulates the stability of the Earth system, which led to the first planetary boundary assessment in 2009 and the identification of 9 planetary boundaries. And I just want to share with you that in 2009, when this was published the first time, we had done a very thorough analysis, but the purpose at the time was really to challenge our scientific peers. This was as good as we could get it. The 9 processes that we proposed, we thought are those 9 that regulates the stability of the Earth system. The big 3, climate system, a stable ocean system, and the stratospheric ozone layer. The 4, what we called slow variables in the biosphere, keeping biodiversity intact, keeping land use systems intact. The freshwater cycle that regulates essentially both climate forcing and biomass growth and habitats on terrestrial ecosystems. And finally, the 2 cycles that go next to the carbon cycle, the nitrogen phosphorus cycles. And that we have 2, or proposed 2, alien boundaries, which are the ones that we have created entirely ourselves, which have nothing naturally to do with the Earth system, namely chemical pollutants that we today call so these are the novel entities, and then finally aerosol loading, which is the air pollution and the black carbon in the atmosphere that in itself can affect particularly hydrological dynamics in the Earth system. We put this out, we quantified 7. We were clear that this was really a challenge for science to really kind of dig and criticize and dig into these numbers. And then in 2015, 6 years later, with a very, very thorough publication list of critical and supported papers suggesting, improved quantifications and critically assessing this whole framework, we landed in the 2015 paper, which I feel very reassured with today because, interestingly, we concluded that there's no scientific support for a 10th boundary. As you can imagine, originally it was quite attractive, the idea of having 10 planetary boundaries. It kind of was symbolic to have come to 10. We couldn't just find the 10th. But there's no scientific support to suggest that we've got one of the 9 wrong and that there should be 8. So that's one conclusion in 2015, that it seems as if we today have come to a point where we could say that if we are wise stewards of these 9 big processes, we stand a good chance of being able to navigate a future within a safe operating space. The quantifications, though, have certainly advanced significantly and continue to be advancing. And as you see in gray here, we still have not being able to quantify neither chemicals nor aerosols nor the functional diversity that determines the resilience in ecosystems, but only the extinction rates of species, which is the number of species on Earth. We conclude that for 4 of the boundaries we are outside of the safe operating space, as you may be aware, and that this is a guide for sustainable development, not a doomsday threat of a world going down the drain. It's saying that on nitrogen, phosphorus, on biodiversity, on land system change, and on climate, we now need to urgently transition back into safe operating space. And that we also highlight the fact that the stratospheric ozone boundary was in the red in the 1980s. We did listen to science. We signed the Montreal Protocol. Industry stepped in, and we transitioned back into a safe operating space. We have done it before. We have been planetary stewards once before in human history. And now we may be on our way to do it on climate. We see a lot of interest in business on the planetary boundary framework. These are just a few examples of businesses and networks of businesses stepping in and trying to operationalize planetary boundaries in their business models. We see countries trying to really see how planetary boundaries can be used as a guide for development. Most recently, quite a major conference actually in Germany, trying to operationalize planetary boundaries within not environmental policy, but really within development policy. We also see many organizations trying to take this framework into their scheme of policy and priority setting. So there is something happening here again in terms of recognizing that we reached this stage of saturation. I just want to reference the Global Environment Facility that recognized that in the Anthropocene we have to have a new definition of global commons. Global commons is something that has emerged, and the whole idea of externalities, once we were a small world on a big planet, that there's something big out there. The big ice sheets, the big atmosphere, the oceans that nobody owns and therefore nobody takes significant responsibility for, and that GEF now sees the scientific support for internalizing global commons in a new definition. This is something we're working on right as we speak. We have in this work identified the 4 transformations that have to occur very rapidly to enable us back into a safe operating space. Not surprisingly, the decarbonization of the world economy, the global energy systems transition, a transformation of cities in the world. We know that 2/3 of the cities in the world to host a world population of 9.5 billion people have not even been built yet. How do we build resilient, sustainable cities is one of the grand transformations. That we need a transformation to sustainable and healthy food systems. We know that food is holding large parts of the determinant future actually. It's the single largest source of emission of greenhouse gases, the single largest loss of biodiversity, the single largest reason why we are in the red on nitrogen and phosphorus, the single largest consumer of fresh water. We get it right on food, we get a large part of our journey back to a safe operating space solved. And that we can no longer go along our linear economic paradigm, but need to have closure of material flows and get the economy to rotate within a safe operating space. We've also translated the climate boundary into a transformational let's say, recommendation from science inspired by Gordon Moore and the Moore's Law, the law that became a self-fulfilling prophecy in the whole ICT industry from the 1960s of doubling the pace, the speed in transistors every 18 to 24 months. And it comes from an analysis based on the planetary boundary work, which tries to ask the question, what will it take to deliver Paris, to stay under 2 degrees Celsius? Well, we know it will take, to number as a first task, to bend the global curve of emissions, shown here in gray. You have carbon dioxide in gigatons, billion gigatons of emissions per year on the y-axis, bending the curve no later than 2020, and then coming down to roughly a fossil fuel-free world economy by 2050, 2060. But we know that that will not be enough. We will also need a transformation, in brown here, of agriculture from source to sink. A major, I would call that an agricultural revolution actually, but not even that is enough. We need to maintain or to scale, whether we like it or not, carbon capture and storage, and start really having negative emissions on the unavoidable energy system that we have installed and that we are still planning to install. And not even that is enough, but you have to maintain the negative carbon sinks. The fact that natural ecosystems here, and terrestrial ecosystems in green, and oceans or marine systems in blue, still take up half of our emission of greenhouse gases in the biosphere. So we emit 40, but 20 are actually still taken up by a resilient Earth system. So this is what can take us to Paris. In fact, it gives us a 66% chance of delivering Paris. Now, this is nothing less than a transformation to a global sustainable future. It is an energy transformation, a sustainability transformation of ecosystems, it is a food transformation. It takes us into the realm of a full global sustainability future. But the gray curve here actually follows a pace, which comes from the IPCC Global Carbon Budget Estimate, that follows a carbon law. Inspired by Moore's Law, it means that to be able to follow that curve of bending down to a fossil fuel-free world economy by mid-century, we need to halve emissions every decade. And if we can halve emissions every decade, just like doubling the speed in transistors every 18 to 24 months, would mean bending by 2020 at 40 gigatons, reaching 20 by 2030, 10 by 2040, and a residual of 5 by 2050. That could take us to Paris in terms of the decarbonization pathway. It's a transformation. We're proposing this and we'll be presenting that in Bonn next week. And the reason why this has gotten some traction actually with businesses adopting it, the World Wildlife Fund has adopted it, is of course that it's scalable, that anyone can adopt a global carbon law. Actually, we could even do it as individuals. You know, any household or family could say, I'm actually going to follow the global carbon law that takes us to Paris, halving emissions every decade. The interesting thing is that you might ask the question, or policymakers do, well, isn't that just utopia, you know, halving emissions every decade? Could we do it? Well, believe it or not, we are actually following the carbon law. This is the latest data from the International Energy Agency, and on the y-axis you have the whole energy mix in the world. So not electricity, energy. And as you see, in gray is from 2000 to 2015, the observations. And you can see coal, roughly 30%, oil, another 30%, gas, another 20%, nuclear and hydro. And then you have renewable energy, the little sliver furthest down there, going from 0.8% to 2.8% in 2015. This classic graph, by the way, is, as you all know, why BP and Shell, and until recently IEA also said, you know, we listen to climate science. We think that the climate risks are important. But we have a responsibility to supply modern, cheap energy to growing economies. And of course, look at that graph. Renewables can never do it. They're ridiculously small. That is often the mantra. But you know, that last 15 years of that little line from 0.8 to 2.8 follows an exponential curve. Actually, the doubling pace of renewables in the world is 5.4 years. Every 5.4 years, it doubles. Now, as all of you know, exponential curves are like that. They actually move very slowly in the beginning, and then they ramp up very rapidly. So what you see here in yellow, the first line there, is just business as usual. It is what happens if we continue as we've done over the last 15 years, doubling renewable energy every 5.5 years. It would actually knock out coal by 2030, it would knock out oil in the early 2040s, and it would take us to a fossil fuel-free world economy by 2050. business as usual. So we're following a global carbon law already today, and we've been doing that for the last 15 years. Now, any economist would tell you, yeah, but innovation pathways always follow an S-curve. You go exponential and then you hit a ceiling, you hit a saturation on the market. Well, who knows? Isn't that perhaps our big challenge? To see to it that we do not hit an S-curve, that the exponential ride just continues. That's why, for example, a global price on carbon is so important. Let me just close with a little bit of a provocation then, which could be a way of just stimulating a bit of a discussion. Well, what does all this mean for macroeconomy? And I'm not an economist myself, and I know we have many real experts in the room, so I take a risk here. But I think there's something more of a moral dimension hitting economy of applying planet boundary thinking. And it would go as follows. Well, we have so much thinking on the need to go beyond GDP and kind of think anew in terms of what do we mean by welfare, not least here at the University of Surrey. We also know that mature, rich economies are not growing as fast as developing countries. So we could perhaps foresee a future with a slower growth, perhaps 2% or lower of GDP growth in the rich part of the world, and perhaps higher in the developing world. That's why I think the whole prosperity without growth thinking is so eloquent, because it takes us to a saturation challenge in the industrialized world. But what I will challenge is the following. The economy, if you take Earth system science seriously, must operate within the safe operating space of the ecology. So the economy has physical boundaries. But the question is, does that mean that you cannot have growth? Well, I would argue that I'm personally agnostic to growth, and that you could think of a future where we do develop within a safe operating space, but allow the economy to grow within that safe operating space. What kind of growth that is a question. I've called this, inspired by Kate Raworth's donut, I thought that this could be a soufflé, meaning that the economy could grow, but who knows how far it grows. It might kind of suddenly collapse down, but I don't see personally that there's a reason to question our ability to have economic development even within a safe operating space. However, it has moral boundaries. And this is work going as follows. So this is the Global Challenges Foundation that brought out a risk indicator after the IPCC's fifth assessment, showing something very dramatic, that even at 450 ppm, which we have reached now for all greenhouse gases, as you know, 400 for CO2, 450 for all greenhouse gases, what is the probability of reaching 4 degrees Celsius, you see in red here, but let's take even 6 degrees Celsius at 450 ppm, because we have this fat tail distribution of risk, which is, yes, we are currently moving towards 3 degrees, but we cannot exclude very much higher temperatures. And the probability, according to the IPCC fifth assessment, of reaching 6 degrees is 1.6%. 1.6%. Well, what is 1.6% probability of reaching what I think even a climate skeptic would agree is a complete no-go area? 6 degrees is a place where we cannot foresee any kind of chance for humanity to evolve. Well, if you take that into the Global Challenge Foundation's risk indicator, comparing risks, it means that a 6-degree equivalent of temperature rise would be, if you compare it with fatal aircraft collapses or accidents, that we would allow over 100,000 fatal aircraft accidents every day. So if we're currently at 450 ppm accepting a risk of 6 degrees Celsius or 1.8%, which would be as if we would accept 100,000 fatal aircraft accidents every day. So it's something wrong in our risk perception here. So let's bring this risk perception with us with a 1.8% probability rate. And this is from the DICE model. This is Bill Nordhaus and the climate economics, and this is how we think about the future in terms of climate economics. You have time on the x-axis and GDP growth on the y-axis, and you see how we're going from our 70 trillion to a projection of roughly 500 trillion US dollar world economy by 2100, end of the century. And then the difference in the curves here is the difference between business as usual, going to 700-800 ppm, and going down to 450 ppm, staying where we are today. And as we've all often heard, it will take us only 1 to 2% of GDP to solve the climate challenge. That's often what we hear. But let's change this graph and put some different entities on the axis and have economic growth on the x-axis and CO2 on the y-axis. So here you have the 500 trillion US dollar global economy by 2100, and you have the blue line is growing greenhouse gas emissions as business as usual. And then you have us bending towards a 2 degrees Celsius limit according to DICE at 550, and then you have the 450 line in green. So that gives a completely different picture of the futures that we are discussing in terms of climate economics. And the interesting thing is that let's put in the risk threshold I just showed you. And let's focus on the upper line there, which is the probability of reaching 6 degrees Celsius, now put at 5% probability. And what this means is that there's a 5% probability at that line's concentration of greenhouse gases of reaching 6 degrees Celsius, which actually means we cannot pass that point because it would take us into a complete disaster domain. So it means that the world economy de facto cannot grow more than to 200 trillion US dollars per year, because that is what I would call a moral no-go zone. You would not, under any circumstances, allow the economy to breach that point where global risks exceed the moral acceptable. Now, I've put this very high. I think there's a strong argument, of course, that this moral ground would be much, much lower. And the question is this in the realm of economics, or is it in the realm of values and equity and morality? And I would argue it has not to do with economy, it has to do with morality. It has to do with a ground, a limit, a boundary beyond which we cannot accept to go. And it doesn't really matter what interest rates or what discount rates or what numbers you put, we will never be able to calculate the cost of breaching that point. So finally then, just to really close, planetary stewardship is therefore necessary based on this Earth System Science advancement. We have the Sustainable Development Goals, which is, as I mentioned earlier, a phenomenal roadmap, a great achievement to humanity. For the first time, we have a social, economic, aspirational journey within planetary boundaries, the Freshwater Goals 6, the 13, 14, 15 on biodiversity, oceans, and climate. We have actually scientifically translated this Swedish kind of smorgasbord, because you know world leaders are behaving very much as if it was a Swedish smorgasbord, picking the kind of favorite goals and doing something on those, despite the fact that these are universal and should be kept together. So we have embarked on something called the World in 2050, which is a scientific collaboration among the integrated assessment modeling groups in the world, those who did the strong work on climate, to explore what are the pathways, the transformation pathways to reach the Sustainable Development Goals in 2030, but see this only as a milestone along the way towards a sustainable future for humanity, where we need to maintain the equilibrium of the Earth system, stay within a safe operating space by 2050. And continue to deliver on the SDGs. So that is one grand scientific quest that is ongoing right now. But we also decided to translate the SDGs to what we call the SDG wedding cake, meaning that if you take the Earth System Science seriously, the Planetary Boundaries actually tells you that there are some non-negotiables among the Sustainable Development Goals, that we can definitely have aspirational social goals, very ambitious economic methodologies to achieve those goals, but they need to stay within goals 16, 13, 14, 15. And that this is a major challenge for our paradigm shift of sustainable development in the future, which actually means, as a final closing graph, I'll give you another equation, that perhaps the future is to transform Mickey Mouse to a wedding cake, which could give us a prosperous future for humanity on Earth. Thank you.
We can't let you escape so quickly. I'd be grateful if you would take a few questions.
Of course. And thanks for your patience. I realize
No, it's wonderful. The timing's perfect. So we can open the floor for some questions from the audience. Who would like to speak? There we go. Max.
Let me take the advantage you're holding the mic. Yeah. It's a fascinating talk. Thank you very much and really insightful. If we going to deploy all the transformations, it will take still about 90 years to reach the Paris target, right? So is that adequate? Is that fast enough? If not, do we need a catastrophic change on the planet to really enable the politicians and the nations to make other dramatic interventions, such as the solar geoengineering type of interventions, because you didn't talk about that.
No, that's a very good question, and this is. I would start by saying that this is the deep fix we're in. That when we have, in the history of humanity, caused upon ourselves different kind of disasters, like the Second World War, we could actually build up Europe after the war. We could actually cross a disastrous tipping point and then recover from that. Now, as science stands today, we have for the first time come to a point where we have to navigate ourselves away from the tipping point before the disasters occur. We cannot allow to cross the thresholds because we don't know how to refreeze the Greenland ice sheet. We just don't have the ability to do that. Now, we cannot exclude that it could be potentially possible. I mean, there are some climate science scenarios showing that you could have an overshoot over many decades and then actually return back and kind of reconfigure resilience in many systems. But I think that's a very, very risky pathway to take. So I think we are at a state where we do not want to allow ourselves, I mean, that's often reasoned in that way, that is it so that political leaders have to be faced with first a massive disaster to be able to act? I think, unfortunately, you could argue, because human nature has always reacted in that way, now we are for the first time facing the need to be wise before the disaster occurs. And we are still in this phase where we still have a slight light in the tunnel. It doesn't appear to be too late to, for example, decarbonize, but it has to happen very, very fast.
Thank you. Thank you. And over there, is that? Kate?
Thank you very much for your lecture. I used to have in my mind a very simple thing, which was the natural step.
Yeah.
Which was essentially that you didn't generate resources at a faster rate than the Earth could reabsorb and look after the the capacity of the Earth to be able to reabsorb. By picking 9, as you've done, I'm wondering if we're missing some of that simplicity and that policymakers might actually miss the need to watch out for things. And the one thing that I'm thinking you might be missing out on is the capacity of Earth to reabsorb. That ability to self-clean is at risk, I think. But I very much like what you shared, but I'm just trying to kind of map the natural step with its beautiful simplicity and your 9 here.
Yeah. No, I really appreciate this question because it's something that often comes up. And let me just say that I have a very close relationship, not surprising, with Carl-Henrik Robert, the founder of the Natural Step. And we have actually published a paper together also showing that, you know, the planetary boundary framework is not the kind of one path to solve everything. It gives us a tool to provide, you know, the aggregate framework, the safe guardrails at the planetary scale, but then across scales within that safe operating space, we need the natural step. We need the ecological footprints. We need the massive efforts at community level to do environmental protection and conservation and management across scales in all sectors. So it's a tool that doesn't replace anything, it complements. And we have, for example, with the Natural Step, suggested that the planetary boundaries can give let's say, the funnel entry point, defining, you know, where things have to add up. That's why I emphasize so strongly planetary stewardship, because that's the drama, really, that we have to stay within a finite global carbon budget. So every nation in the world needs to be collectively acting in the same direction. That it doesn't help if the UK or Sweden does its part if India or the US does not do their part. So there's but that doesn't mean that you don't need to have you know, the local ecosystem management for redundancy and resilience, as you're indicating. They kind of go, I would argue, in tandem together. Like the whole, I mean, we're working very closely now, for example, with Ellen MacArthur Foundation on circular economic, operationalized circular economic business models, and we're combining the planetary boundary framework with circular economy as a kind of a joint framework. So a kind of a cross-scale framework.
Thank you. Bronwyn, yes.
Thank you very much for a great talk. Can I just ask, push you on 2 points, which I know you're asked about a lot. Could you just talk a little bit about the assumptions that you have to make to think that that the negative emission technology is viable? And could you also talk a little bit about the equity issues of carbon regulation as a global approach, rather than, say, Kevin Anderson, Glenn Peters' argument, or Piketty and Chancel? We regulate the 10%, bring them back to Europe's standard, we could reduce immediately our carbon global output by 33%. So why don't we go for some of the heaviest emissions first?
Yeah, no, that's, well, to begin with, I just want to be very clear that until recently, I think many of us share here, and I'm certainly in that camp, were and are until recently very skeptical about carbon capture and storage. Not that it's a technology that cannot work, but that we see no scaling whatsoever. We see no efforts of investment. We see no, we had a few pilots going 5, 6, 7 years back. The technology can work, but we don't see any real efforts there. The reason why it has come back as being something inevitable is that, this is quite dramatic. There are actually no IPCC modeling scenarios in the AR5, in the 5th assessment, that takes us below 2 degrees Celsius that does not include CCS/biological capture and storage. So it's not a value judgment whatsoever. It's just that, it's actually self-critical rather to say that, in these modeling runs, because the curve of emission reduction is in the end seen as not being possible to reduce faster, the only way to keep climate forcing below 2 degrees Celsius is to include CCS. Now the question is, will we see CCS? And that is a big question mark. I'm not convinced personally, which would actually suggest that we cannot exclude geoengineering potentially, which I personally am very skeptical to. But then the only option that remains is to go even faster down to zero, also decarbonize even faster. But remember that I think most empirical research shows that curve, the global carbon law of halving emissions every decade, follows a path we have roughly 6% emission reductions globally per year. 6% per year. Now, I've not seen any empirical research suggesting that we can keep a faster pace than that, meaning that there's some limit in how fast we can decarbonize. So I think we are, in that sense, in quite a dramatic fix actually in terms of the pace that we have to decarbonize, which means I think it's difficult to exclude CCS. Second, on your second question about equity, I totally agree on that. I'm very supportive of Kevin Anderson and the Tom Piketty thinking. I think one definitely should go after the big emitters. I'm strongly with Ottmar Edenhofer and the climate economists that what we need more than anything is a global price on carbon. I think it's an enormous value if nations start really adopting price on carbon. I also think that businesses can, as you may know, there are over 700 businesses in the world today that actually have internalized a shadow price on carbon, which is as a real price on carbon because it actually guides all investments. Something needs to happen here, which I think is the only way to be able to address that distribution of responsibility between the big and the small emitters.
If I might be allowed one on the acceleration, I've got you, so I'll come to it. But you made an eloquent point about the food and the agriculture system, essentially. And do you think enough is being done on that to try to, because that could be, that's a really big lever, I think, to decarbonise.
No, well, there was World Bank has its spring meetings every year, and last year's spring meeting, there was a very, I think, telling conclusion, which is that food, when it comes to sustainability, food is roughly today where climate was 1990, when the first IPCC was born. That we have actually lost 3 decades when it comes to the transformation to sustainable food systems. and that food is to a large extent the lever that has the potential of determining much of our future on Earth. The interesting with food is moreover that just like energy, it has almost this double frustration that we know it's such a big cause for negative pressure on the Earth system, but we also have so much evidence of the solutions. We know how to produce food without emitting carbon, how we can reduce water use, how we can avoid expanding to natural ecosystems, and how we can avoid waste and more healthy food systems, which often go hand in hand with sustainable food systems. So this agricultural revolution is something which is perhaps equally exciting as the energy revolution. But I think we all share here who are involved in this that much is happening on the food area. It's remarkable how many things. I think the IPES panel on experts on ecological agriculture with many UK scientists is phenomenal. I think it's fantastic with the EAT initiative now. There's things bubbling on the food agenda, I think.
There was a question there, yes.
Hello, thank you for your talk, Johan. You mentioned during the talk that there were 9 planetary boundaries, and you said that scientists have ruled out a 10th one. I wanted to ask why human population is considered a planetary boundary.
Yeah. No, thanks for that question, because it's good to sort that one out. So, and this may make you a little bit disappointed perhaps, and I disappoint my staff every time I say this, because I'm leading an interdisciplinary research center where we take social science and natural science as an integrated part of sustainability science. But you should think of the planetary boundary analysis as being a return to disciplinary science. We actually mentally took the world population away from planet Earth for a while and just thought of the Earth system, just the planet, and just ask ourselves the question, what are the biophysical processes that regulates the ability of the Earth system to remain in the Holocene? That is the only thing it does. It doesn't do anything more than that. It just tries to ask within what quantitative boundaries can we have a high likelihood of remaining in an interglacial Holocene state. That gives us a safe operating space, and then we put humanity back and say, please, dear humans, let's prosper inside that green space. If we're 7 billion or 9 billion or 11 billion is in a planetary boundary context irrelevant. So we don't care. The numbers are not set depending on what humans need, which was part of what the limits to growth did actually. It is only set in terms of what does it take to have a high chance of staying in an interglacial state of the Earth system. So that's why population is not one of the boundaries. And that's why Kate Raworth's work is so important, because she puts humanity inside. She says if we have a biophysical ceiling, there must be a social floor. There must be a floor of equity, of demand, of needs, of aspirations, and that is inside the safe operating space. So she has in a way invented the full planetary boundary framework. We put out just the biophysical part of it.
Okay, I think we've probably got time to take one more question. So the lady up. Oh, sorry.
Yes. So I was wondering, you talked about the soup plate effect on the economy. A lot of the companies, they're always talking about growth. If it's not growth, it's cost cutting and everything, and they have to maintain very optimistic numbers. And every company that you hear about, they're always aiming for 20% growth or something, and they're always exploiting the markets. Why don't we just try to aim at changing that perspective? Because growth really is a very old-fashioned way of thinking all the time, where there are companies like Apple who have exorbitant amount of cash. They're just piling up, not really using. Which is, honestly, it's like, it doesn't even make sense having that amount of cash and just not working with it. They could do sustainable stuff, projects all over the world. So how do you see like global economy or companies taking this approach? And how do you see, is this growth-driven economy always at the center of most of the companies, or most of the people you talk to are CEOs and everyone, are they always emphasizing on that? Or is there some sort of change in mindset and change in trend, where people are less focused on growth and more on sustainable and shared economy and we have a shared value and stuff like that.
Mm. Mm. Yeah, well, I should start by saying that I think that's a question that should, I guess, go to you, Tim, really, as the author of Prosperity Without Growth, rather than me. But just to share with you that I don't have the answer. Your question is phenomenally important, and as I mentioned earlier, I'm personally kind of agnostic to whether or not we have growth. I think the key is welfare, it's human well-being. I think there is. I do see a trend in business, particularly in big business, recognizing that sustainability is no longer a corporate social responsibility challenge or just something you greenwash in some sustainability report, but that sustainability is actually influencing business models, that we see a trend line towards decarbonizing business, but also having more circular business models, which may mean growth, but a different kind of growth. Like, for example, shared business models. I mean, I just came before here to this Wired network session in London that presented phenomenal, innovative startup companies based on shared economy. There's a company called Ofu, which is sharing bicycles around the world with digital technologies and satellite positioning systems. They had 2 million bicycles in China. A fantastic new business. So that's one part of your question. But then also to say that, I mean, I might close then with another little punch then I'm looking forward to a follow-up discussion, that I think we need to regulate. I don't think we can wait for values to change in the business mentality in the world. We need to transition the world back into safe harbor space in 30 years, in almost one generation. So we need the political leadership to set the regulatory frameworks within which business operates, and that we have to have enforcement for that. So I think that's why the legally binding climate agreement really is something that political leaders next week must stand up and say, we don't care about the US at this point. We are moving ahead decisively. So the signals go to business that there's no alternative than to start recognizing that we are at the beginning of the end of the fossil era, period. And that and signals are coming so strong from China. We are so proud today, can you imagine, in Sweden, that Volvo cars have announced that they're now going electric. Well, I can tell you, it wasn't us Swedes that made them go electric. It was the Chinese, because Volvo Cars is owned by Geely, a Chinese company. That's where the drive is, and that is very positive. So I think we need to have a recognition of the regulatory role of guiding this transformation as well, and then have innovation within this safe operating space. But I think it's not as easy just to try to change values. But I think there is reason to be quite optimistic of what's happening, at least in the mindset of many businesses around the world.
Thank you very much. And thank you very much for
Thank
your
you.
questions.
Thank you.
Well, it gives me great pleasure to be able to thank Johan Rockström and his colleagues for helping us understand the importance of the biophysical frameworks within which we need to live on this shared planet. What becomes clearer each and every day is the difficulty we have, the difficulty we face in understanding, in coaxing, in informing, and in shaping the human response to these boundary questions, and how we can help shape the politics right for ensuring that we can produce a response that keeps us within these boundaries so that we can all hope for a sustainable future. Johan, you may have noticed that the UK politics has been dominated by only one or two issues at the moment, giving limited political bandwidth for much else. And it's been really good to remember this evening that there's a huge global debate that we need to be part of, and that has nothing to do with whether we're going to crash out of the EU with no deal. Sometimes I think it can be a bit of a thankless task, and I know that you've been travelling all the way around the world with this powerful message that we've been able to hear tonight. It may seem a bit of a thankless task, making the same argument again and again. But bit by bit, I firmly believe that we all need to occupy that space, to have the narrative, to be able to demonstrate the mastery of the argument. You've given us a very strong, compelling narrative, so powerful, so visually stunning as well, and so firmly based in hard, unequivocal fact. It's an extraordinary tour de force. We may be well beyond 1990, but I think we as your audience haven't reached our saturation point. As chair of CUSP's advisory board, I know we have the pleasure of working with you and your colleagues at the Stockholm Resilience Centre, and it seems to me to be the perfect partnership, combining these complementary skills of natural and human sciences, and in particular with this very strong purpose and mission of seeing how knowledge can help shape a different, better future. I think we've got a little present for you, which we very much hope that you will accept, in really to give you a memento of your time here this evening. We will remember the messages that you've given us and the wonderful set of images that you've provided for us, which have been, as I say, a visual delight. So, Johan, thank you very, very much.
Thank you so much.
Wonderful. Thank you. Thank you very much. And thank you to all for your attendance. It's my happy duty at this point to say a thank you as well to many people who've helped us put this together. It feels a little iniquitous of me to single out individuals, but I would like to mention three, if you'll forgive me. So first, Charlie Engel there from our events management group, who has really done a wonderful job for us. Thank you very much, Charlie. And two individuals from CUSP and from CES that I would very much like to thank personally, who put together really the whole show. First, Deirdre Richardson, I would like to give thanks. Do come forward, Deirdre. And also Linda Gessner. So is Linda here? Perhaps not. So, thank you. I did wonder whether you might be phobic about this sort of thing, Linda, but it's a pleasure. And so it really just brings me to close this. Thank you very much for coming. Safe journey home, and I'm sure we'll all carry great hope for the future, actually, and great messages. The information in here will be made available on our website. Yes? Thank you. So please visit the CES website. Ouch. Thank you and good evening.